Imagine standing beneath a vast night sky, staring at the shimmering glow of the Milky Way, a river of stars stretching across the darkness, each point of light a sun, many with their own planetary systems. It feels eternal, unchanging. But what if I told you that this peaceful cosmic scene is an illusion of time? That right now, beyond the limits of human perception, galaxies are locked in an immense, slow-motion collision, one that will reshape the very fabric of space. And not just any galaxies, but our own far beyond our lifetimes, but inevitable in the grand clockwork of the universe. The Milky Way and its closest galactic neighbor, Andromeda, are on a direct collision course. The event is set to unfold over billions of years, a slow gravitational dance of unimaginable proportions. But this is not a rare cosmic anomaly. Galactic collisions are a fundamental part of the universe's evolution. We've witnessed them in stunning detail across the cosmos, captured by powerful telescopes peering deep into the past. These encounters create dazzling celestial structures, twisting streams of stars, violent bursts of new suns, and even the merging of supermassive black holes, releasing cosmic shockwaves that ripple through spacetime itself. Yet, for all their violence, galactic collisions are not the chaotic, star-smashing catastrophes one might imagine. The universe is vast, far vaster than our everyday instincts can grasp. Even when galaxies collide, the individual stars within them are so far apart that direct stellar collisions are incredibly rare. Instead, what unfolds is a titanic struggle of gravity, where entire solar systems are displaced, new stars are born, and the very shape of a galaxy is rewritten. So what actually happens when two galaxies collide? How does such a spectacle unfold? Over millions and billions of years. And most importantly, what does this mean for us? Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. To understand a galactic collision, we need to step back and look at how galaxies behave in the grand expanse of space. Galaxies are not stationary islands floating in the void. They are in motion, carried along by the expansion of the universe, tugged by the gravitational pull of other massive structures. While some galaxies move away from each other due to cosmic expansion, those within the same gravitational cluster are inevitably drawn together. Andromeda, for example, is hurtling toward the Milky Way at a staggering speed of over 500,000 miles per hour. At this rate, the distance between our galaxies, currently over 2 million light-years, will shrink over the next several billion years until their outer edges begin to interact. At first, the two galaxies will merely brush past each other, distorting their shapes through immense tidal forces. Picture a slow-motion car crash, where both vehicles remain mostly intact, but are stretched and warped from the impact. The powerful gravitational tug will pull long streams of stars outward, forming what astronomers call tidal tails, enormous, glowing bridges of stars and gas stretching for hundreds of thousands of light-years. These tails, seen in colliding galaxies like the Antennae galaxies and the Mice galaxies, are some of the most visually stunning structures in the cosmos. But the first encounter is only the beginning. Over millions of years, gravity will draw the galaxies back toward each other, setting off a second collision, then a third. With each encounter, the once-defined spiral arms of both galaxies will unravel into a chaotic, swirling mass of stars, gas, and dust. Massive shockwaves will trigger an era of intense star formation, a phenomenon astronomers call a starburst phase. As clouds of hydrogen gas compress and collapse, new generations of stars will be born in rapid succession, some burning brightly before meeting a violent end as supernovae. Yet, even in this cosmic upheaval, our own solar system might remain relatively undisturbed. The vast distances between stars mean that while our galaxy's structure will change, the Sun and Earth will likely drift along with its motion, barely noticing the chaos playing out on an astronomical scale. However, that doesn't mean we'll be untouched forever. As the Milky Way and Andromeda continue their gravitational battle, their central supermassive black holes will begin spiraling toward each other. In the final act of this collision, these behemoths, millions of times the mass of the Sun, will verge in an event so powerful it will send gravitational waves rippling through the cosmos. The two galaxies will ultimately fuse into a single massive elliptical galaxy that scientists have already named Andromeda. But what will the night sky look like when this happens? Imagine a future Earth, billions of years from now. Instead of the soft cloudy band of the Milky Way, the sky will be dominated by the glowing core of an entirely new galaxy, an enormous sea of light stretching across the heavens. And perhaps, if humanity or its descendants still exist, they will look up and wonder about the stars just as we do now. But before that day comes, the process of galactic collision will bring countless surprises. What happens to planets caught in the gravitational chaos? Could new habitable worlds form? And what does this tell us about the fate of other galaxies throughout the universe? The story of a galactic collision is not just one of destruction, it's also a story of creation. As two galaxies interact, their gas clouds slam into each other, compressing and igniting an era of frenzied star formation. This is what astronomers call a starburst phase, a period where thousands, even millions of new stars are born at an accelerated rate. But not all stars formed in these collisions are created equal. The most massive ones burn hot and bright, exhausting their fuel in just a few million years before erupting into cataclysmic supernovae. These explosions scatter heavy elements, iron, gold, uranium, into the cosmic void, seeding the building blocks for new planets and perhaps even life. One of the most striking examples of this process can be seen in the Antennae galaxies, a pair of colliding galaxies located about 45 million light-years away. Through powerful telescopes, we can witness their dazzling transformation, a tangled mess of stretched-out stars, glowing nebulae, and massive, chaotic regions of star formation. The violent interaction has left behind spectacular tidal tails that span hundreds of thousands of light-years, filled with newly born stars shining like cosmic fireflies. These breathtaking collisions provide us with a glimpse into the Milky Way's own fate, allowing us to predict how our home galaxy will change over the next several billion years. But while the creation of new stars is a beautiful outcome of these encounters, it also leads to some of the most extreme and dangerous phenomena in the universe. As the newly formed stars go supernova, they release shockwaves powerful enough to trigger more star formation in surrounding gas clouds. However, if too many stars explode in a short period, they can clear away the very gas needed to form the next generation of stars. This is one of the paradoxes of galactic collisions. While they can fuel incredible bursts of new life, they can also strip galaxies of their ability to create future stars, pushing them into a slow evolutionary decline. And yet, in all this chaos, one thing remains largely untouched: individual stars. As counterintuitive as it sounds, stars within colliding galaxies rarely, if ever, crash into each other. The distances between them are so immense that even when galaxies merge, the odds of two stars physically colliding are incredibly slim. To put this into perspective, if the Sun were the size of a ping-pong ball, the nearest star, Proxima Centauri, would be over 500 miles away. Space is mostly empty, even in the densest parts of a galaxy. Instead, what truly defines a galactic collision is the unseen force of gravity, which reshapes entire star systems, altering their orbits and sometimes ejecting them entirely. These rogue stars, flung from the chaos of merging galaxies, can travel at breathtaking speeds, sometimes exceeding 1,000,000 miles per hour, becoming lonely wanderers drifting through intergalactic space. Some may carry entire planetary systems with them, exiled into the cosmic abyss. If Earth were to be caught in such an event, the consequences would be unimaginable. But here's the good news. Current models suggest that our solar system is unlikely to be thrown into deep space when the Milky Way and Andromeda collide. Instead, we'll likely migrate into a new position within the merged galaxy, with no immediate catastrophic effects. However, while stars themselves don't often collide, something else does: galactic cores. Every large galaxy harbors a supermassive black hole at its center, and when galaxies merge, these monstrous voids are inevitably drawn toward each other. At first, they spiral closer in a slow gravitational embrace, warping space-time itself. As they near their final moments, their orbital speeds increase, whipping around each other thousands of times per second, before finally merging in a cosmic event so powerful it releases more energy in gravitational waves than all the stars in the universe combined. This process has already been observed in distant galaxies, and with instruments like LIGO and the upcoming Laser Interferometer Space Antenna, LISA, scientists hope to detect these titanic black hole mergers as they send ripples through space-time. The merger of the Milky Way's supermassive black hole, Sagittarius A, with Andromeda's even larger central black hole, M31 Sud, will mark the climax of our galactic collision. The final result? A single massive elliptical galaxy, one lacking. The elegant spiral arms of today's Milky Way, but likely filled with a dazzling concentration of old and new stars, and yet the universe is never static. Even after the Milky Way and Andromeda merge, the newly formed Milkomeda won't be alone. Our galactic neighbors, like the Triangulum Galaxy, the third largest member of our local group, may also be drawn into the mix, leading to an even larger cosmic merger. The entire local group of galaxies over time may coalesce into one enormous structure, bound by gravity in an endless cycle of creation and destruction. But what does all this mean for life in the universe? Could a galactic collision make conditions more favorable for life to emerge elsewhere? Could it create new Earth-like planets in habitable zones? And perhaps most importantly, what happens to the night sky as this unfolds? The answers might change everything we think we know about our place in the cosmos. As the collision between the Milky Way and Andromeda progresses, the night sky will undergo a transformation unlike anything humanity has ever witnessed. Over the next few billion years, Andromeda will continue to loom larger and larger in our sky. If intelligent civilizations exist on Earth during this time, they will see a breathtaking celestial dance unfold. Andromeda's once distant spiral arms stretching across the heavens, glowing brighter each night. Eventually, the two galaxies will appear as one tangled mass of stars, gas and dust, locked in a gravitational struggle. But what would happen to Earth itself? Surprisingly, life on our planet may continue largely undisturbed, at least for a time. The vast distances between stars mean that direct collisions between solar systems are exceedingly rare. However, the gravitational chaos of a galactic merger can have unpredictable consequences. The Sun, along with the entire solar system, will likely be displaced from its current position in the Milky Way's spiral arm, possibly flung into a new orbit closer to or farther from the newly formed galactic center. Such a shift could have serious consequences. If we drift too close to the turbulent core, radiation from the supermassive black holes and dense stellar regions could expose Earth to more extreme cosmic rays and gamma bursts, increasing the risk of mass extinctions. If we move farther out, we may find ourselves in the lonely outskirts of the new galaxy, where star formation has long since ceased, leaving behind only dim, aging stars. But before Earth can fully experience the impact of this cosmic event, another fate may await us. In roughly 5 billion years, the same time frame in which Andromeda and the Milky Way will be in their final stages of merging, the Sun will reach the end of its main sequence lifetime. It will swell into a red giant, engulfing Mercury, Venus, and possibly even Earth before shedding its outer layers and leaving behind a white dwarf. By this point, our planet may be uninhabitable, with or without the effects of a galactic collision. If humanity or its successors wish to survive into this far future era, they will need to seek a new home beyond Earth, perhaps in a young star-forming region of the newly merged galaxy. And what of the long-term fate of the Milky Way-Andromeda collision? After billions of years of chaotic interactions, the newly merged structure, sometimes called Milkomeda, will eventually settle into a vast elliptical galaxy. The spiral arms that once defined both galaxies will be gone, blended into an amorphous, featureless mass. Unlike spirals, which have active star-forming regions, elliptical galaxies tend to be old, with most of their gas depleted. Star formation will gradually decline, and over the course of trillions of years, the remaining stars will slowly burn out one by one until only dim remnants remain. But the story doesn't end there. The newly formed Milkomeda will not exist in isolation. Our local group of galaxies is currently being drawn toward an even greater structure, the Virgo cluster, part of the massive Laniakea supercluster. Over hundreds of billions of years, gravity will continue to pull these structures together, eventually merging them into a single, unimaginably vast collection of galaxies. This process is the natural evolution of the universe. Small structures collapsing into larger ones, a cycle of cosmic recycling that has been occurring since the dawn of time. Yet, as these grand mergers unfold, the universe itself is also changing. Due to the relentless expansion of space, driven by dark energy, distant galaxies are being pushed farther and farther away from us. As a result, in the far future, beyond 100 billion years, an observer within Milkomeda may find themselves in a dark, empty cosmos where all other galaxies have drifted beyond the visible horizon. The night sky, once filled with billions of distant galaxies, may become eerily silent, with only the stars of Milkomeda remaining. But before that distant future arrives, the universe still holds countless mysteries. Could galactic collisions trigger the conditions necessary for life to flourish elsewhere? Could entire civilizations rise and fall over the course of these cosmic events, shaped by the gravitational ballet of the stars? And most intriguingly, if intelligent beings exist in another galaxy, are they watching us right now, pondering the same cosmic questions? As we look to the skies, witnessing the slow-motion dance of Andromeda's approach, we are reminded that we are part of something much greater than ourselves. Our galaxy is not a static, unchanging island. It is a traveler, part of a vast and ever-evolving universe. And in this grand cosmic story, we are just beginning to understand our place. So, what do you think? If you could witness the Milky Way and Andromeda collision firsthand, would you want to? Let us know your thoughts in the comments below. And if you enjoyed this journey through the cosmos, don't forget to like, share, and subscribe to Cosmic Whispers, where the mysteries of the universe are just waiting to be explored.